Alright guys, I'm going to try this video today. I'm actually holding it with my hand because I haven't gotten my contraption to work. So if it's a little shaky, I apologize. I promise each time I'll make it better and better. But today's lesson we're going to talk about ordering and exponents. So the first thing we're going to talk about is what is an exponent and what does that mean. So if I give you the number 3 with a little 5 at the top, the 5 is called the exponent. And the 3 we call the base. So basically what the exponent tells a number is the number 5 tells the number 3 how many times to repeat itself by using multiplication. So this would be read as 3 to the 5th power. And if I was to actually write this out in what we call expanded form, it would look like this. 3 times 3 times 3 times 3 times 3. Okay, so we have the base number 3 repeated, and it repeated 1, 2, 3, 4, 5 times. So 3 to the 5th power is the same thing as multiplying 3 by itself 3 times. Okay, so the first thing we're going to do is I'm going to give you some numbers that are expanded, and we're going to write it in what's called exponential notation. Right? Using exponential notation. And all that means is when you write something using exponential notation, the word notation is just like a note. So basically a shorter way to write the numbers to be multiplied. So for example, number 1, if I give you 2 times 2 times 2 times 2, we can write that a shorter way using exponential notation, so a note with an exponent. So the number being repeated is the number 2, that is our base. How many 2's are there? 1, 2, 3, 4. So we would write this as 2 to the 4th power. See, these two are the same thing, but this is a shorter way to write it, hence the word note. What about one like this? What if we have 3 times 4 times 4 times 3 times 4 times 3? Let's add another times 3. Notice on this one we have two bases. We have a number 3 repeated and we have 4's repeated. Now this whole thing is multiplication, so it does not matter if you write the 4's first or the 3's first. What matters is you have the right amount of times repeated. So let's start with the number 3. I have 1, 2, 3 3's. So first I'm going to write that as 3 to the 3rd power. Another special name for the 3rd power is cubed, if you hear people say that. So 3 to the 3rd power is the same as 3 cubed. Oh, I forgot one, sorry. There's actually 4. Let's crash that out, my bad. We have 3 to the 4th power because there's 4 of them, sorry about that. But we still have some 4's left, and this all is one big multiplication problem. So we're going to use a dot to represent multiplication, and I have the number 4 repeated 3 times. So I'm going to write that as 4 to the 3rd power, or 4 cubed. So on number 1 we had 1 base, 2 was our only base, and on number 2 we had 2 bases, but it's still a shorter way. This is shorter than writing all of these numbers expanded out. Let's do one more, but this time with letters. So let's say I have A times B times A times A times A. Okay, the same thing applies to letters and numbers. So this time our bases are letters. So I have letters A and letter B. Again, it doesn't matter which one you put first. I might just start with the first one I see. So I have 1, 2, 3, 4, 5. I have 5 A's, so I'm going to write that as A to the 5th power. And how many B's do I have? I have 1, so I'm just going to write times B. Now, anytime you have just one letter or one number, it's an understood exponent of 1, meaning we don't need to put the 1 there, okay? If you put the 1 there, it's not wrong, it's just not needed, okay? So this is all we need. A to the 5th power times B. All right, the next thing we're going to talk about is what it means to evaluate. sorry, this is hard, I'm using one hand here. When you're asked to evaluate something, I think of that as how it sounds. Evaluate has the word value in it, so it means to find the value, meaning actually get the answer and find the answer, okay? So let's call this number 1. If I give you 9 to the second power, and by the way, another name for 9 to the second power is 9 squared, if you hear people say that. So 9 squared does not mean 9 times 2. It means the number 9 repeated twice, so it means 9 times 9. And what is 9 times 9? It's 81. So we evaluated 9 squared and found out that it was 81. Let's do another one. What about if I have something like this? 8 to the 4th power. Again, this does not mean 8 times 4. It means the number 8 times 8 times 8 times 8. So in this case, we have 4 8s. So what we're going to do is just multiply from left to right and keep building our answer. So 8 times 8 is 64. Notice I put a box around it, and I do that because that shows me what I've used and what I haven't used. And then I just brought down each 8 that I haven't used yet. Now, we can either do 64 times 8 or 8 times 8 first. It doesn't matter because it's all multiplication. So let's just say I do this one. This 8 times 8 is 64, but I still have another times 64. Now, you can use a calculator in this class, so it's not cheating. So if you want to pull out your calculator or use the one on your phone, 64 times 64 is 4,096. Okay, now we just did that the long way, the longhand way. I want to show you another way on your calculator to do this. So if you have this calculator or on your phone, you should be able to do it too. So on the first one, if I want to do 9 squared, 9, this caret button to the second power gives me 81. If I want to do 8 caret 8 to the 4th power, I did 8 caret 4 equals, I got 4,096, which is the same thing I got down here. Now, you can certainly use your calculator. I just wanted to show you this way so you understand what's actually happening, because like I said, a lot of people think this means 8 times 4 versus 8 times 8 times 8 times 8. Okay? Now, there's one more I want to talk about here on the evaluate side. Number 3, what if we have 17 to the 1st power? What do you think that would evaluate to? What does that mean? 17 to the 1st power, it basically just means 1 of the base 17. So if you just have 1 17, your total is 17, right? So anything to the 1st power is just itself, 17, okay? All right, so that was all for evaluate. The next thing we're gonna do is talk about expanded form. So we're going to do the opposite, basically. I'm going to give you some numbers, and we're going to stretch them out and write what those actually mean. So let me get another piece of paper. I'm going to put write using expanded form. Okay, so for example, number 1, if I gave you 8x squared times y cubed. Okay, now in this one, all we're doing is writing an expanded form, and to expand something means just to stretch it out. So I'm basically going to take these and write them out. So I have the base 8. I only have 1 8. So remember, when there's no exponent, that's an understood 1. So I have the 8. My next base is x squared, so that means I have 2 x's, times x times x. And then y cubed tells me I have 3 y's, times y times y times y. And make sure you put a multiplication sign in between all of those, because this whole thing is a multiplication problem. So we did what it asked us to do. We just took it in standard form, what we call this, and we wrote it in expanded form. We stretched it out based on what the exponents told us. But what about something like this? Let's do 5a to the 4th power. So what is this one telling us to do? Anytime you have something in parentheses to an exponent, that means whatever is inside here, all of this together 4 times. So this would be written like this: 5a times 5a times 5a times 5a. Okay? Another way to think about it, to stretch it out even more, is to separate the numbers and the letters. So we have 4 5s times we have 4 a's. A times A times A times A. Okay? And this is the most expanded you can get. So you can basically think of it as you're doing 5 to the 4th power times you're doing A to the 4th power. Okay? The next thing we're going to do is talk about some theorems for exponents. And theorem is just a fancy word for something you can prove based on known results. So there's a couple of theorems we're going to talk about with exponents, and these may be familiar to you. If not, this is new for you, but we're going to title this Exponent Theorems. Now, each of these actually has like a special name, but I'm just going to call them 1, 2, 3, and 4, just because the name of it's not really the point of it. So the first theorem, so I'll just call this number 1, says if we have a base to an exponent times the same base to another exponent, that's the same thing as taking that base and adding the two together. So a to the nth power times a to the nth power equals a, and all we do is add the exponents. Let me give you an example. 2 cubed times 2 to the 4th equals, so there's nothing wrong with 2 cubed times 2 to the 4th right now, but a lot of times in math we just try to write things as simple as we can. So they'll say write it using a single exponent. So instead of leaving it like this, since we have the base repeated, we have the number 2, and the theorem told us to add our exponents, 3 plus 4. Okay, and we can simplify that even further. My base is 2. What is 3 plus 4? It is 7. So my final answer is 2 to the 7th power. So make sure you know that these are the same thing. 2 to the 7th power is the same thing as 2 cubed times 2 to the 4th. This is just a simpler way to write it. And if I wrote this out in expanded form, 2 times 2 times 2 times 2 times 2 times 2 times 2, and I counted all of them, I would have 7 of them. Okay, and so that's why that makes that theorem true. The second theorem says if we have a base to the nth power and all of that to the nth power, all we have to do is multiply m times n. So make sure you remember that when a number is next to, or I'm sorry, a letter is right next to another letter, that means multiplication. So all we're going to do is multiply our exponents. So for example, if I had 7 to the 5th power in parentheses, 7 to the 5th power, I want to take all of that to the 6th power. That's telling me to do 7 to the 5th 6 times if I was to write it out. But instead of writing it out that long way, we can use this theorem that says I can just multiply 5 times 6, which is 30. So 7 to the 5th carried to the 6th power, simpler, we can just write that as 7 to the 30th power, okay? And when we're doing these, we're not actually going to evaluate 7 to the 30th or 2 to the 7th. We're simply just showing how we can simplify this and write it using one exponent, okay? Number 3, this theorem says if you have the same base to the nth power divided by, again, a and a are the same base, n, that's the same thing as doing the base and subtracting the exponents. So notice up here with multiplication, we added the exponents. With division, we are subtracting the exponents, okay? So if I gave you something like this, 8 to the 10th power divided by 8 to the 4th power, that's the same thing as taking the base 8 and simply doing 10 minus 4, which gives me 8 to the 6th power on that one. Sorry about that. 8 to the 6th power. 10 minus 4 gave me 6. Okay, and then one last little theorem, or law if you will. Anytime you have any whole number that's not 0 and you take it to the 0 power, it equals 1. Okay, so if I give you 5 to the 0 power, it equals 1. If I gave you 100 to the 0 power, it also equals 1. Anything to the 0 power other than 0 will always be 1. So here's your theorems again if you want to get a better look. Okay, I'm going to stop the video now and I'm going to make a second video for order of operations.